please consider sponsoring me on Patreon. The link is in the description. You'll be helping me to build open source innovation automation solutions and also develop a low-cost 3D metal printing project as documented on my other YouTube channel, Calabal CNC. Thank you. Hey Internet peoples, so I've really got to say that I like developing with this video system because well, it does take longer, so there is that frustration. Normally I like to go really fast when I'm developing code. However, I do really like the fact that I've got video coming down, and every keyboard type that I do shows up here, and I'm able to go back and make corrections and see how much of a stupid idiot I was on this while I was writing the code. So I'm going to go back and correct some of the mistakes that I made in the last episode. String to data type. I made some changes here. I made some mistakes. And this param has to be fixed. So I never put that properly. Not that it really matters. But I'm just taking notes of stuff that I missed, which is really, really good. Another one that I noticed is Boolean. This one, let's see, here it is. I don't have cases for off, or off. So I think that was the only one missing there. I think we've got it covered with this, so that's good. I just needed to update that header. Another one is integer. Oh, well, I was going to add that I should check for these upper and lower bounds, but I guess I'll deal with that later. And I could probably do that by actually like trying to parse as int and then see if it actually parses or not. That might be a quick way to determine that. Another way here, because obviously it's not going to work if it doesn't. So I'll come back and take a look at that in a little bit. Is string, I think, is another one I need to look at. And let me double check. Actually, there might be some other stuff. Let's see here. Value of, yeah, there we go. I'm going to just try to keep these from being run-on sentences that go off the screen too much. So that'll help clean that up a little bit. Just need to keep those run-on sentences from getting too long. Yeah, some of these are probably okay. Not so much for these. Okay, just trying to clean this up so it doesn't, stuff doesn't run off crazy long. Okay, I'm just going to sort of scrub through the file and make sure that we don't have stuff that's going on way too long, like this one. Yeah, that one's a little bit okay. Right here. I should probably move that back and do this here. Okay, and yeah, okay, make sure, just scrub through the file, make sure we don't have stuff that's going on way too long past the line. Some of these are okay. When they get a little bit long, okay, and that's looking mostly okay. All right, so is string, and let's see here. Here's another one I'm going to look for. Okay, and I think the problem here is we wanted to change these replace to, instead of doing it that way, to just calling this replace character with character. So I'm calling the business rule instead of doing this. It might not be quite as efficient. And if efficiency becomes a bottleneck or a problem, then we can look at it then. But as of right now, it's not. So I'm just going to call that, and then we'll pass it input data. And then I need to give it an array, followed by this global regular expression. Not like that. Okay. And b.c double quote. Okay. Now I've commented that out, but only because I need to actually run the unit test to validate this and that it behaves correctly. I have a unit test that we're going to implement to be able to do this, to unit test this. So once that runs and this can be validated, then I will remove this quote. I'll probably have to scrub through this file when that happens. I'm going to do the same here, just so we have a commonality. Return data. Yeah, see, look at that. That wasn't even the right one. Return data should be like that. That would be a mistake. Equals input data dot. I'm sorry. This should be replace character with character input data. And then the array with b.c double quote and b.c single quote. Okay. So I'll do the same thing there. I'll once this is done, then this comment will be removed. Following the Yagni principle, you ain't going to need it anymore. We want to remove it. So I'm only leaving it in there until we get that unit test built, which will be basically when we finish everything up. So I'll probably have to scrub through all the files at that point anyways. And clean carriage return from string is another one that I think needs to be adjusted accordingly. Yep, right here. So let return data equal replace character with character input data, and then we have our regular expression system is s plus /g, and then I think it's b.c space. I think it's space character. That's the essentially the same. Should be declared as that. So let me see. Yep. So that's b.c space. That's correct. And again, following the Agni principle. Oh, we do need to have a trim on the end of this. Dot trim. Okay. So yeah, that's still needed. And the next one is, it's kind of, like I said, it's really nice to be able to review the footage of me programming and see exactly what it is that I need to fix. And then we have let return data equal replace character with character input data. And the regular expression, this one was the one that we dealt with last time. Should be the same. I just got to go through this very carefully. Plus $/. And then we're going to replace it with that. Okay. All right. This is another function that needs to be corrected. Swap / to $. There is this param right there. Oops, I made it worse. Backslashes. Okay. And replace character with character. And it looks like there's an issue right here. So we've corrected that now. there's another issue here. Convert string to lowercase. So with no uppercase, this needs to change because of that word no in front. And this one has no, so this needs to change to lowercase. Okay. All right, I guess that's it. So I think we're ready to get started implementing the new stuff. Let's save that, and let's get finished with this file as much as we can. Okay, and yeah, here we go. All right, so the functions that we're implementing now, a lot of them are going to be useful. Some of them are going to be useful for building our runner, and some of them are going to be useful for doing Const's unit testing, which is we'll see how all of this stuff plays together. But these are sort of the fundamental pieces that we need to be able to do some of those advanced things. So like I said before, this is a business rules system, and building all these business rule functions is sort of like laying the foundation work for all the cool stuff that'll happen later. So maybe a little bit boring right now, but trust me, this is the stuff that makes the difference for all the work that's going to be coming later. So here we go. The first one is export const get value from assignment operation string equals function, and again we have similar stuff that we've been doing all this time. There we go. Okay, and this is going to be a little bit different in how we set this up, but we do have the ending that does have to match up. So let's go ahead and set that up as well. Same as we've been doing so long. Oh, well, before I do that, we do need to continue to follow our pattern. And there is, like I said before, there is still quite a lot of stuff to get through. So let's go ahead and try to get through it. At function, there's that. At description, parses the input string and finds the value on the right side of the equals sign. Basically just returning whatever's on the right side. And it's going to take a string. This one is a string, and it also returns a string. Okay. The string that should be parsed for the value on the right side of the assignment operator. Okay. Not used for this business rule, typical. And the string value of whatever is on the right side of the assignment operator. Assign it. Date. Okay. Now the implementation here is, we're going to have a little bit different here. We say parsed string equals input data dot split b.c equal, and we're going to need to set up some logging, so just to be able to help the debug in the case that we are needing to debug this function. Then it will already be, the debugging will already be in place. So I'm going to clear the message formats and parsed string term1 is, oops, I need to, sorry, that needs to go inside a string literal. Parsed string term1 is parsed string and the 0th element of that array. And then we're going to have another one here, parsed string term2 is plus parsed string the 2nd element of that array. Okay, and then finally we have let return data equal parsed string 1. And actually, this is going to be a replaced. I don't want to do this. Well, I'll write the code out first because this is what has been what I have been using in the past. But I'm going to immediately go straight to the new system, just like that. And then we have a close square bracket plus /G for global, and that one. Okay. We're going to immediately comment that out and say let return data equal replace character with character parsed string 1, and then we're going to pass an array for the metadata and the regular expression. Actually, it's this one. Let's just copy it. Okay, and that. Now that should be the equivalent, but using our native business rule. Okay, and again, we'll remove that once we go through and reunit test all of these things. Okay, so the next one, this one is good. It's especially good for parsing the XML data because we want to get those values. Next is, did I make sure I get that right? Get value from assignment. Yes, okay. All right, so the next one is export const, and we're going to be using this one to help write our automation test runner. It'll basically parse command line arguments. Aggregate, oops, make sure I spell correctly. Aggregate numerical difference between two strings. Okay, and this one is a little bit more of an involved function. There's some significantly more complicated logic for this one. Input data, input metadata. This function name needs to come down here. Then we have the begin, the input metadata, the input data, and this requirement is going to be a little bit different. We're just going to declare our return data here. Return data, and we have to do some conversions before we actually proceed. So convert the input string to lowercase and clean them up for parsing. Okay. Let string 1 equal import input data dot to. Yeah. Well, what we should do is call our business rules here. I'll just no. Input data dot to lowercase, and then replace, and we're replacing this another regular expression, but I would like to I'd like to do this with our business rules, but I have to do it with both of them. Let string 2 equal input data and input metadata. I'm sorry, metadata dot to lowercase dot replace, same basic global expression, regular expression. Okay. Alrighty. Okay, so again, I'm going to copy these out, and we're going to change these up to be with the business rules system. So let string 1 equal convert to lowercase, and then we're going to just pass the input data. But actually, from here, I need to actually call, rather than just calling that, I need to call replace character with character, and inside there we pass input data and our array. Now, with the regular expression. Now the question is, I think I need to analyze this a little bit because I think this is normally evaluated first and then this should be evaluated, and if that's true then that'll work because this should be evaluated first followed by that call. So one good way for me to check that is again to unit test it. So that's something that I'll have to be doing later, but I do have this one to fall back on and the code is there as an equivalence. So that should at least get me going. Let string2 equals convert string to lowercase. Again, replace character with character, input data, and the array with the regular expression. There we go. Okay, so that should do the same thing. And then we need another comment here. Build some arrays of variations on string 2. We will use these for doing the comparisons. And again, this is basically, we're just doing what this is telling us. We're basically determining a numerical value that sort of figures out what the difference between these two strings, these two input strings are, and basically lets us like have a deterministic value for how closely matched the strings are, which helps us with determining if something is close enough to be an equivalence within the string system. So let variation 0 equal array string, oh, I didn't get that right, string 2.length plus 1 dot fill, I'll fill that with zeros, dot map, a map function here, and vi arrow function I, and let variation 1 equal array string 2.length plus 1 dot fill just zeros. Okay. And then we need to do some logging. Actually, you know what? I never did some logging on these because after we modified the strings, the string inputs, then technically, oops, and this actually needs to change to metadata. I need to be working with this properly. So that needs to be metadata. And even this, yes, that one is metadata. So I just didn't copy it correctly. Okay, but we do need to add the loggers. So this logging system needs to be implemented because we've modified these two strings now. So we got two new strings, and those need to be basically logged. We need to know what it is how the modification has been going so far. String, oops, this is a string little here. String 1 is, oops, string 1, and it's going to be basically the same here. Again, these loggers are not going to log every time I execute this function. The code may be executed, but it'll come right back out of this. It like goes in, and within the first few lines of code, if the configuration for this is not set up properly, then it comes right back out of there. So we're talking like nanoseconds. It's pretty quick. These don't really affect performance. And so string 2 is string 2. So we've logged those, and then down here we need to log our variations as well. It would be basically that. So we know we basically modified these, and I got some variation variables, arrays, and we need to know what it is that we're dealing with here as well. So let's put those together. Variation 0 and variation 1, variation 0 and variation 1. Okay. All right. Now ultimately, all of this needs to go back to here. So let me make sure, I never actually got the end of this thing put on here. There we go. And I need to go ahead and write my header. I never wrote my header. Let's do that before it gets out of sight. Okay, at function, it's basically that. Okay, at description, determines the delta difference between the two input strings and returns it as a number. Okay. So we're going to have a string, and this will also be a string, and it's going to return an integer. Okay. Okay. String 1 to compare, and string 2 to compare. And return the delta difference between the two strings expressed as a number. And sign it. Okay. Alrighty. Hold on. All right, so the purpose of having these map array functions, really, or these array data, is basically we're going to loop through everything through the one of the strings, and we're going to see if the other one sort of maps on. And so as we loop through, we're going to as we loop through each character in the string, we're going to basically construct what you would call like a match map, or an array of values that indicate ones or zeros, probably ones where we have a match and zeros where we do not have a match. And basically once those values are tabulated up where there's zeros, then we can use that to determine how closely matched the strings are. So that's basically the algorithm. We're going to have two nested for loops here to do that. So let me separate the algorithm from the rest of the code here. And then we'll have for let I equals 0, I less than string 1 dot length, I plus plus, and we have this. Okay, so we're going to have another logger here because we need to log each step of this. This is, like I said, is a little bit complicated algorithm, but it's not beyond being debugged. And if we do need to debug it, then we should be able to. So the literal string here is I value is, and then plus I. So you can basically log which step we're on. Variation 1, and the 0th element of that equals I plus 1. Okay, and then we're going to have another loggers function to log another component here, and the message on this one is variation 0 value is variation 0. Okay, and that should be the end of, or the beginning part of that loop. And then we have our second our for loop here. First nested for loop for let j equals 0, j less than string 2 dot length, and j plus plus. Okay, and this one, and we're going to document these as well, and j loop, and this one is going to be and I loop. Okay, so that way we're very clear as to where the beginnings and endings and which loops and what those braces are doing. Here we have another logger statement. It's going to basically be the j component. Oops. Oh my goodness. Okay. J. This will change to J. And this will change to J. Okay. Next is let deletion cost equal variation 0. And that is J plus 1 plus 1. Let insertion cost equal variation J plus 1. And let substitution cost, we're not going to do that. That has to be a computed. So if string 1I equals string 2J, then substitution cost equals variation 0J. Okay. Else substitution cost equals variation 0J plus 1. Okay. And then we're going to have some loggers here. So let me just go ahead and copy paste a bunch of these because we need to log all the data that is going as we're processing through these loops and this logic. So there's 1, 2, 3, 4, and 5. This one is not. This one is actual logic. So, and this message is going to change. Each of these messages is going to change. So let's just wipe them all out, and we'll define each one individually. Okay. So deletion cost is plus deletion cost. Okay. This one is insertion cost is cost. And this one should say substitution cost is plus substitution cost. All right, now we have to do the logic here, which is variation 1 J plus 1 equals math.minimum deletion cost, insertion cost, and substitution cost. Okay, and then we have the loggers. And we say variation value is variation 1. Okay, so that's the end of the J loop. And then we do a few wrap-ups. So let temp equals variation 1. Variation 1 equals variation 0 to swap. And then variation 0 equals temp. And that's the end of the J loop, or the I loop, sorry. And then there's the end of the function, but we still have to set up our return data. Return data equals variation 0 string 2.length. Okay. And then we have the return data logged, and then we're actually returning it. So we got some little bit of logic there, like I mentioned before. These guys will need to be changed out and verified once we run a unit test on this thing. Other than that, I think we're good to go on that one. So yeah, now we're ready to start the next one, which is export const convert camel case string to array. All right, function and return data. Okay, this needs to come here. And then we have the very end. And we'll go ahead and write a header for this function. Convert camel case string to array. Description takes a string in camel case and returns an array of the words. So this one's just going to be string and array of strings. Input data, string to decompose into an array. Not used for this business rule. And this should say the array of words that were composed in the original string. Sign it. $10.21. Okay, there's one additional note here. At note might not work so well with numbers as part of the string. They are not treated as capital letters. We might need to do some refactoring of this function if mixed numbers and camel case strings ever becomes a requirement as input to this function. Okay. So the implementation for this, we're going to have let capital letters equal empty array. For let I equals 1, I less than input data dot length, I plus plus, if g.c uppercase English alphabet dot includes input data dot char at I. We're going to have an implementation right here. Capital letters dot push I. And I need to space this out just so it's clear that that's the implementation of that if condition. And this is the end of that line. And that's also the end of that for. Okay. So one line implementation. I know that I put this, the end of this out here. It's a little bit weird. Sometimes I know that you're supposed to space these out, but when it comes to this, it's sort of like the old style C++ implementations for those of you who are Windows programmers. For single line implementations, that can be a nice way to consolidate extra lines of code. If capital letters dot length is greater than 0, oops, I need to close that up. Okay. Let last equals 0. let decomposed string equals an empty array. And we have another for loop here. For let j equals 0, j less than capital letters dot length j plus plus. Okay. Decomposed string dot push input data dot slice last capital letters j and capital letters j and yes, right there, dot to lower case. Okay. Yeah, last equals capital letters j. And then we have decomposed string dot push input data dot slice last dot to lowercase return data equals decomposed string, and then down here we have an else. Return data equals input data dot to lower case. The rest of that stays the same. Okay, yeah, that's another interesting implementation. And then there's a few more like that. Convert camel case string to array. And this one is export const convert array to camel case string. Basically the reverse. Okay. Alright, so this is technically like a family of functions that we're going to be implementing here. So let's just go ahead and put them here. And they're all kind of related a little bit. And the wrap up as well. Okay. And there'll be a very small implementation like some of the other ones. And the function name convert array to camel case string. That one needs to put right here. Okay, and the header for this looks like this at function convert array to camel case string. Okay, description takes an array of words and returns a camel case string of the input words. Okay. All right. So it'll take as input an array of strings, just string, sorry. There we go. And this is string. And this will also be string. Okay. The array of words that should be strung together into a single long string. All right, and for the input metadata is not used for this business rule. Okay, and the return, a string that contains all of the words from the input array put together in sequential order. Okay, and sign it. 1021. All right. And yes, okay. Now the implementation, let's double check this. Convert array to camel case string, convert array to camel case string. All right. Implementation here is, I'm going to go ahead and just say return data equals input data dot map key index. And we're going to pass that to an arrow function. Map word to camel case word key and index. And we'll see that here in a little bit. We're going to actually implement that next. Okay, so that's the return data, and we're ready to move on. So the next one is export const map word to camel case word equals function input data. Actually, I keep forgetting right here. Okay, so map word to camel case word. We need to convert this right here for our definition, and then let return data equals followed by the wrap-up. And a header. Okay. At function map word to camel case word at description takes a string key and an indexed string value and maps the word to an uppercase first letter word. Okay. And the input for the input data type is string. This is also string. And it's going to return a string. Okay, input data, the string key value that should be converted to a camel case word. Okay, input data, the string index for the map to the value that should be used. Okay, and return a string where the word has been converted into a camel case word. Sign it. All right, now the implementation is input data dot replace regular expression character arrow function character dot to uppercase. And again, I probably should replace this with the other function call. Let's go ahead and do that. Let return data equals replace character with character and the input data and the array with these two same things. There we go. That should work. We've got export const simplify and consolidate string equals function. So this here again. Let return data equals, okay, and then the end of it. right, simplify and consolidate string. That function and description takes a string and returns a version of it converted to lowercase with all digits and symbols and white space removed. And there appears to be a bug in this one. But I'll note what the problems are. And it actually looks like this one is not really working that well. So like I said, I'll take note of it. And if there is ever a business need for this, then we can come back to it. Okay, input data, the string that should be simplified and consolidated. Input metadata not used for this business rule. Ultimately, I think we could use this to like logically control if we want to remove numerical values or not from the as part of the consolidation algorithm. You know, like optional parameters. But for now, this works. A string that has been simplified and consolidated by converting to lowercase, removing all digits and removing digits, symbols, and white space. Okay, sign it. Date and a note. I think this function is not completely working as expected. Probably something to do with the regular expression. Input was 11 Uber or upber driver 321 code clearance 0x hashtag 0000 FF aka blue. It's a reference to Star Wars. Code clearance blue. For those of you who are familiar with Return of the Jedi. Anyways, output was 11 upber driver 321 code clearance 0x0000 FF aka blue. So it did remove some of the special characters. The dash took everything to lowercase, but it obviously didn't remove any of the numbers. So there seems to be a bug with this. As you can see, there are still some numbers coming through. Might need to revisit this one when time allows, and if there is ever a business need again. Okay. Yeah, and the implementation of that is just and it actually this could really be an issue with Lodash as well, because that's what I've been using for this particular implementation. Replace input data dot to lowercase, and the regular expression is like this. Okay, /G for global, and then there's that. So yes, yeah, and that seems to be an issue. It could be Lodash as well that's causing the problem. possibly maybe even the combination of Lodash and the regular expression. But I'm not too worried about that. Let's move on to the next one. Export const compare simplified and consolidated strings equals function return data equals right to there, and then this part as well. Okay, compare simplified and consolidated strings. Did I get this? Simplify and consolidate string. Yep, we got that one. Double check all of these. Convert array to camel case string. I think I'm doing okay. Camel case to string to array. Okay, yeah, I think we're good. All right, but this one, obviously not yet. There we go. And the rest of it is okay. Now we just need to write the header. It compares simplified and consolidated string. Okay, at function compare simplified and consolidated strings. Description is compares two strings by their simplified versions. See simplify and consolidate strings. String. Okay. All right. Takes a string and returns a Boolean. Okay, input data. The first string to be compared. Okay, the second string to be compared. A Boolean value to indicate if the strings are virtually identical or not. And the author, sign it. Okay. And the implementation is just simplify and consolidate string. And then we pass in the input data equals simplify and consolidate string, input metadata. And should actually have like that. Actually, no, that works just fine. Okay. Oops. Yeah, that didn't work quite as I was expecting. Nope, still not. I'm not sure what's wrong with that thing. I think I need to do like that. Yeah, because this is going to resolve this to a Boolean value, and that'll be the return data. Yep. Okay. All right. Okay, so this next one is export okay, here we go. So this next one is export const does array contain lowercase consolidated string equals function down to here. Okay, compare simplified and consolidated string, and does array contain lowercase consolidated string. And then this part right here. All right, let's write the header for that. At function does array contain consolidated string? Okay, at description checks if an array contains a string, comparison made by lowercase and consolidated string. Okay, so that should be an array of string. And this should be a string. And this will be a Boolean. Oops. Okay, input data. The array of strings that should be checked if it contains the specified string. And this one, input metadata, the string we are looking for in the array. And the return is a Boolean to indicate if the string is found in the array or not. And I'll assign it. All right. Now the implementation looks like this. Okay, so for the implementation of this function, we got let return data, and we're just going to declare that. And then we're going to have another one that says let string data equal value 1, value 2, arrow function to aggregate numerical difference between two strings, which we've already implemented, value 1, value 2, and that's essentially going to be for less than 2 Boolean, so that'll evaluate as a Boolean, and then sorry, string data. No. How's that going to evaluate? Okay, less than 2. That's an interesting. Okay, and here. String data, and then we have to output a message. So we're going to output string delta. Yeah, this is if it's essentially if it's less than 2, then it'll evaluate to true or false string data. This should not be string data. This should be string delta. That was my confusion. Okay. Basically, if it's less than 2 characters of difference, then this will evaluate to true. So string delta value is plus string delta. Okay. And then we do return data equals does array contain value input data, input metadata, and string delta. And then we return that. Okay, so that way I've got a debug statement in there that helps us debug that if there is ever a need to debug it. And then we come down to the next one. Export const does array contain character. Okay, equals a function. Okay, and then we come back up to this part for the wrap-up. Does array contain character? Okay, that needs to go right here. Does array contain lowercase consolidated string? Okay, and then here, go ahead and implement our header. At function. Does array contain character? description parses through all the elements of an array and determines if any one of them contains the input character. Okay, input parameter. This one is going to be, could be a string, Boolean, an integer, or an object. Okay, and this is an array of string or Boolean or integer or object. And it's going to return a Boolean. Input data, the character or value that should be searched for in the array of elements. Okay, and the metadata, the array that should be searched for the specified character, value, etc. And this should return true or false to indicate if the value was found or not found. And author and date. Okay. So that implementation looks like this. False. Set that to false first, and then we're basically, if the condition evaluates true, then we'll prove it is true. If not input data and not input metadata, return false. And actually, now that I think about it, I think I'm going to probably be refactoring a lot of the logic for some of these business rules. And I think I have a better way of doing this, but we'll do that when I'm all done. And then I can just show you basically how I'm going to implement a new sort of filter logic on the inputs to make sure that we have good case handling on that. So I'll come back to that. But for now, I'm just going to keep going. We're going to have a for loop here. Let I equals 0. I less than input metadata dot length and I plus plus. Let array element equal input metadata, and we want the ith element of that. Okay. If array element dot includes input data equals true, then return data equals true, and we should actually break because we don't want the loop to continue in that case, and that should be the end of that one. So the next one is export const remove character from array equals function. Okay. And the wrap up. And then this goes right there. Does array contain character? Does array contain lowercase consolidated string? Okay. Just double checking the work again, and I think we're good. Okay. And the header for that is at function remove character from array description is removes all instances of a character or value from all array elements. Okay. And the input data is a string or an integer or a Boolean or a float or an object. Input metadata is an array of string, Boolean, integer, float, or object. Okay, and the return type is just going to be an array of string or Boolean or integer or float or object. Okay. Input data should read the character, integer, Boolean, float, or object to remove from the array. Input metadata is the array. Yeah. I need to clarify this. This needs to be a little bit cleaner. Float or object. That should be removed from all instances of the input array. And I want to come down here. Let's clear that down there. Okay. This is the array from which all instances of the input character, integer, etc. should be removed. Okay. And this one is the array after having the specified character removed from all elements of the input array. Sign it and date. Okay. Now the implementation. Again, we're going to say the return data equals false, and if not input data and not input metadata, return false. For let I equals 0, I less than input metadata dot length I plus plus. Okay, inside that loop, let array element equal input metadata, the ith element of that, and if array element dot includes input data equals true, then input metadata ith element equals replace character with character array element, and this time we're going to actually use a regex expression constructor. Regex expression, oops, sorry, that's not right, should be this one, plus input data .cg for global, and that. Okay. Yeah, that's kind of a cool little implementation, and then we'd say return data equals input metadata. There we go. yeah, kind of a neat little implementation there. All right, next one is export const ascertain matching file names. Function and return data. Okay, remove character from array. I always keep going back and checking those. I learned my lesson the hard way there. Okay, and then on the downside for wrap up we put that. Give some space for implementation and go ahead and implement a header. At function ascertain matching file names at description compares two file names after stripping off the path and determines if they are matching or not. Okay. String, and this one is a Boolean. Okay, the first file name and path that should be used in making the file name comparison. Okay. And this one, the second file name and path that should be used in making the file name comparison. Okay, and the Boolean return a Boolean value to indicate if the file names are equivalent. Okay. And date, author, sign it, and date. All right, as for the implementation, return data is actually just like that. And then we have if path.baseName input data equals path.baseName input metadata, and then we say, well, there's going to be a logger here, so I need to go ahead and put messages because this helps with debugging, and this is used as part of our path system, which means it's going to be used for loading stuff and working with files. So file names match, return data equals true. Should probably set this to false just for the declaration purpose. Else, and we're going to grab both of these because there's just a few changes there. File names do not match, and we change this to false. Everything else should be the same. Okay. Yeah, that's looking good. Alright, so the next one is export const does array contain file name. Okay. And next, need to make sure and ascertain matching file names. Yes, this one needs to go right there. And then this one comes here. Okay. All right, let's go ahead and write the header for that. At function does array contain file name. And at description, the description is checks if an array contains a file name after stripping off the path. All right, array of string, and this one is just a string, and this one is a Boolean. Okay, input data is the array of file names that should be checked for the input file name we are looking for. Okay. Input metadata, the file name we are looking for in the input array, and the Boolean is a Boolean value to indicate if the file name was found or not. Assign it. Fortunately, we're getting near the end of 2020, so hopefully this crisis year will be over with for everybody. And this needs to be false. Okay. Return. Oh, well, actually, wait a minute. I don't need to have false there. I can just say, well, actually, yes, it does. False. Okay. Return data equals does array contain value. Input data, input metadata, and wait a minute. That doesn't work. Oh yes, that's right. Ascertain matching file names. Yeah, that's right. This should go like that. So I think this is a function that I'm going to implement later. It's an internal function, and it doesn't actually follow the same business rule format, but we also don't export it. So it's basically a supporting function that's only used by business rules for this very specific need. I don't know. If we need to refactor it, we can, but it seems to be all right. Okay, so I think alternatively, I do have that other function that looks for arrays that contain values, so I possibly could, I think there's another one up here that matches, does array contain character, and this one takes an array of objects that could be anything. So maybe I could call that and sort of refactor this. That's something to consider, which I don't know. We'll sort of get there if I need to. This can be looked at later. It's not really a high business requirement right now anyways. And I think what I have here does work pretty good. All right, so let's move on to the next one. Export, const, validate, const. Oh yeah, that's right. We're starting to work on the constants unit testing now. Constants data validation. Okay, equals and function. Okay, so we've moved on from that other stuff to this new stuff, and validate constants data validation. Okay, and there we go. All right, return data equals false. Yeah, I want to go ahead and bring this together, wrap it up. Okay, and we've set that up. Let's go ahead and write the header. That function validate constants data validation. Description validates that validation data to ensure that all the constants contents of the constants validation data matches with the actual constants definitions. There we go. And basically, this is kind of cool because we're validating the validation. It's sort of a two-tier system. We want to validate that that the constants are the way that they're supposed to be, but we also need to validate that we're validating them correctly. Like essentially that we've validated the right things, or that we validated everything that needs to be validated. We haven't missed anything. So there's this two-tier validation, which you'll see implement. These are the basic functions that support that that type of capability. Boolean, and from here, input data, the path of the constants file that should be validated. So in this case, I think it's actually scanning the constants code and then making sure that we've written validation for all of the lines that are in those files. The name of the data hive that contains the appropriate matching constants validation data, because we store all that validation data for the purposes of validation on the B data structure. We'll see how it works here in a second. True or false to indicate if all of the contents of the constants are fully validated or not. Okay, sign it. And date. So I think I mentioned that we were going to be doing this at the beginning, and this is one of those functions that enables us to do that. So it's kind of cool. Okay, so return data false, and again we'll just add a comment here, set it to false, and we will prove if it should be true. Okay. And then let found a failure equals false, and const linear equals new line by line input data. So we're going to scan through and let line equal like that. So this is what's going to allow us to scan through each line of code in that constants file. So while line equals liner.next, and then we have a loggers. So we need to make sure we've got these in here to be able to log our debugging capabilities. And the message changes. Oops. So it's not that message. It is line.toString g.c ASCII, and then we say let line in code equal line.toString g.c ASCII. Okay, let found constant equals false. If line in code dot includes s.c export const equals true, let line array equal line in code dot split b.c space. So it's going to parse, it's going to split that line of code up so that we can parse it. And then we're going to have the loggers message is going to be here again with a different message. This time line array 2 is plus line array 2. That's the loggers. Found constant equals validate constants validation. Oops, that's not correct. We're going to have it's a different function we haven't written yet. Validate constants data validation line item name, and we pass line array 2, and input metadata. So we'll write that function in just a little bit. If found constant equals true, then we have a nested configuration here. If configurator.get configuration setting s.c display. We don't have this one yet. Display individual constants validation pass messages. If that is true, then we're going to have a custom message with some custom formatting. Let pass message equals pass. Oops. There plus line array 2 plus pass. Okay, pass message equals chalk.rgb 0, 0, 0. Pass message. So that's going to colorize the background, not the background, the foreground of that message. And then pass message equals chalk.background RGB 0, 255, 0 is going to give it a nice green color. And let's make sure we have that keep that nice and clean. And then we'll say pass message again. Okay, and then we'll just do a raw console.log pass message. In other words, we're not using our other system there. Else, and then we're going to have another configurator here to do something similar. Hold on. All right, so for this else condition, we have else if configurator.get configuration setting s.c display individual validation fail messages. Okay, so I'll just do that and then change this to fail messages equals true. Then let fail message equals fail plus line array 2 plus fail. All right, now we're going to do some formatting here. Fail message equals chalk.rgb 0, 0, 0. That's the foreground for that message. Fail message, and then fail message equals chalk.background RGB 255. That's going to be red 0, 0. And then fail message. This should be fail. Fail message. Okay. Yes. All right. Console.log fail message. Console log fail message. Now we're going to do let suggested line of code equal determine suggested constants validation line of code. Line array and 2. And that's a function we haven't written yet, but we're about to write it very soon. If suggested line of code is not equal to then suggested line of code equals chalk.rgb 000. So that's the foreground of that font. And suggested line of code. Okay, and we're going to set the background. Oops. Suggested line of code equals chalk.background RGB 255 00. So with a nice red background, suggested line of code. Okay, and then of course console.log suggested line of code is suggested line of code. Yeah, so that makes for a nice little thing there. And then we'll have found a failure equals true. And then we've got another if condition we need to do here. If found a failure equals false, then return data equals true. Okay, there you go. And that's the end of that. All right, so the next function, next business rule is export const determine suggested constants validation line of code. I'll be implementing that very one that we said we would implement. So let's make sure we get the basic setup here like we've been doing. Okay, and this time we're going to set it directly to the input data. Okay, and then the wrap up, the typical pattern here. Okay, and let me double check that. Did that get changed? Validate constants data validation. Yep, so we're going to go ahead and change this one. And let's write the header. At function determine suggested constants validation line of code description takes the name of the missing constant and determines a suggested line of code to add to the appropriate appropriate constants validation file. Okay, this will make it really easy for developers to maintain the constants validation system. All right, and this is a string. This is a string, and this is also a string. So the input data is the name of the constant that is missing and should have a line of code generated for it for validation. Not used for this business rule. And the return is the suggested line of code that should be added to the appropriate constants validation code file. Sign it. date 10/22. Okay. All right, now the implementation is if input data dot char at 0 equals b.cc. Basically, is it basically beginning as a constant? All the constants should be declared that way. So let literal value equal input data dot substring 1. Return data equals, and then we have this has to be the backtick because we're going to have some inline code here. Name, and then this $, and curly, open curly brace, input data. And then after that, we have actual w dot $, again, and open curly brace, input data, the expected should be $, open curly brace, literal value, and then we have the end of that followed by the end of that followed by that. There we go. Okay, else console.log error attempted to generate a suggested line of code to validate the constant plus. So we have a little bit of a run-on sentence here, but the constant is not formatted correctly. It should begin with a lowercase c. Another sentence. Please reformat the constant correctly so a line of code can be generated for you. Okay, and then return data equals an empty string. Okay, and then the rest of it is the same. Yeah. All right. Okay, so the next function, business rule, is export const validate constants data validation line item name, and that's equals function. So we'll come back up here, same as that. Okay, equals, and let's double check, determine suggested constants validation line of code. Okay, and this one needs to change for here. And come down and we wrap up, do the wrap up. There we go. Okay. And the header for that is function validate constants line item name. Okay, description is loops through all of the constants validation data and verifies if a matching constant definition can be found or not found. Okay. All right, and these guys, of course, are strings. string, and this one is a Boolean. Okay, input data. The constant definition that should be searched for. This one is the name of the data hive that contains the appropriate matching constants validation data. Okay, and the Boolean return is true or false to indicate if a match was found or not found. Oops. Okay, sign it and date. All right, now this should be initialized to false, and we come down here and we'd say for let I equal 0, I less than d s dot c constants validation data. Oops, that belongs inside there. And then we put the input metadata here, dot length I++, and that's the beginning of our for loop. Okay, so let validation line item equal d, and it's basically the same, all of this. Okay, except this has an I on it. To get the ith element out of that, if input data equals validation line item dot name, so if that's true, return data equals true, and we break, so we don't keep looping unnecessarily. And the rest of this is just perfect. So the next function is export const validate constants data values. Okay. Alrighty. And wrap up. Okay, validate this one. And the header for that. At function validate constants data values. Okay, and description. Iterates over all the constants values in the constants validation data specified by the input parameter and validates the context. Okay, this is a little bit long. Okay, and the data types here are string, and Boolean. Oops. Okay, input data says the name of the data hive that should contain all of the validation data that should be used to execute the validation procedures. And like I said before, that's a little bit long, So we'll cut that short, loop it around, and here this input metadata not used for this business rule. Return true or false to indicate if the validation passed for the entire data hive or if it did not pass. And sign it. Date. Okay. And the implementation is, again, this time we're going to set this to true. And here we say for let I equal 0, I less than d s.c constants validation data. And then we have input data dot length, similar to what we did before, I++. Okay, let validation line item equal, and I think it's the same here. We probably have that I, same iterator like we did before. Yep. And if validation line item dot actual equals validation line item dot expected. So if that's true, then we have if configurator dot get configuration setting s.c display individual, is this a pass or fail? It's a pass messages. So if that is equal, oops, is equal to true, okay, if that's true, then we let pass message equals, and we do this backtick again because we're going to have inline code, pass dash dash $, curly brace, input data, actual, $, curly brace, validation line item dot actual, expected, $, validation line item dot expected dash dash pass. Okay, oops, there we go. All right, and then we'll take that and we're going to format it like we did with our other messages. A pass message equals chalk dot RGB 000, 0, 0. Okay, and that is applied to the pass message. And then we're going to do the background, same as we did before. Pass message equals chalk dot background RGB 02550 to indicate a nice big bright green background. Pass message. Okay, and then console.log pass message. That actually dumps it right to the console. Okay, then from here, we're going to have an else case. And the else case looks like this. Return data equals false. And if configurator dot get configuration setting s.c display fail message individual constants validation fail messages equals true, and then we open curly brace there. Alrighty, so this is the beginning of that condition, and I think it's just going to be pretty much the same. Let fail message equal backtick fail dash dash $, curly brace, input data, actual, $, curly brace, validation, line item, dot actual, expected, $, curly brace, validation, line item, dot expected. Dash dash fail. Okay, so then we say fail message equals chalk dot RGB 0, 0, 0. We apply that to the fail message. Okay, fail message equals chalk dot background RGB 255 for red, 0 green, 0 blue, and again we apply that to the fail message. Okay, and then console.log fail message. Okay, and we come down here to the end, and that's it. All right, next function. Actually, I want to put a note in here, sort of a manual note. The following functions business rules are more domain specific because these are a little less generic and a little bit more very specific to what we need to accomplish for other things. It turns out that they are very much still framework specific, but a little less general. So let's just go ahead and get through these. There's not a whole lot of them. Export const get data category from data context name. So this is kind of more like data handling, but it is still string manipulation. So let's see here. Function, it's still much the same. Function. Did I get that right? Validate constants data values. Yep. Okay. Still down here. Get that first. Okay. And then the wrap up. Okay. Now the header for that function get data category from data context name and description gets the data category from the context name, e.g. example input page underscore project list data category is page. Okay. And this should be a string. Metadata is a string, and the return type is also a string. Okay, the input data is the data context name, which should also contain the data category separated by underscore. You've got to keep them separated. Sorry, bad joke. All right, not used for this business rule. And the return, the data category such as page or test. This is sort of how we manage, it helps with managing data for a page object model. Author, date. Okay. All right, return data. Actually, before we do that, we want to go back to our old format. If not input data, return false. And like I said, I'm going to be doing some refactoring here. Let the return data, and then let data category equal input data dot split b.c underscore return data equals data category 0. Okay. Yeah, return data. There we go. Oh, there's one more there's one more log I want to put here, and that's what it should be returning, just to make sure that they're the same, that it's actually. So the message I want to put here is data category should be data category 0. That way we've got what it should be, and we got what it actually is returning. It's very clear what the expectation there is. All right, so export next is constant get data category detail name from data context name equals, and then function. Okay, let's put that right here first thing. And the wrap up. Okay. So the header function get data category detail name context name, and the description gets the data category detail name from the context name. Example, input page underscore project list data category is project list. Okay. So this is a string. This is a string. And this is a string. Okay, the input data, the data context name, which should also contain the data category and data category detail name separated by an underscore. Okay. This one is not used for this business rule. The data category detail name, such as project details or project list, and sign it and the date. All right, so for the implementation, let data category detail name equal input data dot split b.c underscore, same as what we had before. And in this case, return data equals data category detail name 1. So we're just returning the other side of that equation. And I am going to have a similar line of code to that. Data category detail name should be, and it's this one, and we put a 1 there instead of a 0. Okay. All right. Okay, so the next function is export const get keyword name from data context name, and this is useful for implementing keyword framework. So it's actually almost completely identical. Just copy the whole thing. Wait a minute, did I get this name correct? Detail name from data context name. Okay, it's virtually identical. There's only a few very minor changes. Make sure we change that first. Okay, and this needs to change to data category keyword name. Okay, so that's the same, but instead of 1, 0, 1, it's now going to be 2. Input data, that's the same. This changes to 2. We changed that already, and I just need to add a header. Add function, get keyword data context name description gets the, hang on just a second. All right, gets the keyword name from the context name, e.g. input is keywords project details delete entire project. So if that's the case, then or another example would be a return essentially would be keyword is delete entire project. So that's what the return would be. All right. And string and string. Okay, for the input data, the data context name, which should also contain the data category and data category detail name, and I'm going to break right there, and keyword name separated by an underscore. All right. Metadata not used for this business rule. And the return, the keyword name such as delete entire project or edit project info click, for example. Those are just some examples. Sign it. $10.22. Okay. All right. So I think everything here is implemented correctly. Let's go on to the next one, which is the function that we've been actually trying to get to all of this time. Export const parse system root path. And that was the one function that we said we were going to implement when we started this whole process. And now we're going to actually do it. Equals Okay. All right, and the wrap up, just capture that part of it. All right, now let's go ahead and put this right here. This is one of those things we need to be able to even load the data that we're going to be working with. All the data pretty much. And so the header is add function parse system root path. Description parses the root path as returned by calling path.resolve dir name. This business rule looks for the app name part of the path. And will parse that out to determine where on the hard drive this app name folder is installed at. Okay. This takes a string, and returns a string. So the input data, the root path as defined by calling path.resolve underscore dir name. Okay. The metadata not used for this business rule. And the return a string with the path up to the application folder, wherever that is installed on the local system executing the tests. Assign it. Okay. All right, now for that implementation, we're going to return set it to an empty string. Let application name equal configurator dot get configuration setting s.c application name. Oops. Okay, and let path elements equals input data.split b.c backslash. Okay, and then we're going to define a loop 1, and inside there we're going to have a for loop. Let I equals 0, I less than path elements dot length I plus plus. Okay, so that's the beginning. And loggers dot console log. Okay, well, we're just gonna put these guys in here. All right. All right. Now the message is, begin iteration I, the ith iteration. Okay, it's for debugging because this one could get kind of messy. Let path element equal path elements I. Now there's a thing, if we're trying to load the configuration file, then we're not going to be able to log this. So if I ever needed to debug this, then I would need to hard code console logs. But that's besides the point. Okay, let's put another one in here. Okay, path element is path element. Now, after that, we have another if condition. If I equals 0. And we have another loggers. Oops. All right. Case I equals 0. So we're just tracking every little bit of what we're dealing with here. Return data equals path element. Okay, now here we have an else if path element equals application name. If that's true, then we have another loggers. Okay, and that is case path element equals plus application name. Return data equals return data plus b.c backslash plus path element plus b.c backslash and break loop 1. Okay, else another console log, and here we're going to document case else return data equals return data plus b.c backslash plus path element. Okay, and then after that we're going to have two more console logs. Okay, this one says return data so far is plus return data, and then we have end iteration I plus I. There we go. And then that's the end of our loop, but we still come back to here and return data equals swap double backslash to single backslash. We're just going to shove the return data in there. Empty string. Okay. And then we have another return data equals swap backslash to forward slash and return data again. And there we go. So that should be all fully cleaned up. Okay. Yep, that should do it. So next function is export const replace double percent with message. And we're going to use this for part of our logging system, so it's very important actually. I believe earlier here's the thing. Some of these functions are called, these business rules are called by the logging system. Like I said, this one is going to be pretty important for the logging system because it's how this double percent is a delimiter for log messages, and messages are going to be handled a little bit differently. For instance, we colorize them. We colorized the data component of a message separately from the message component itself. So there can be different ways, but this double percent plays a key role in that. Is one of the delimiters that we feed in, and then we parse it out, and that's what this function is doing or helping to do. But because we were calling this stuff a lot of times from the logger functions or chain of functions in the loggers classes or loggers files, it would ultimately cause a circular dependency, which would trigger an infinite loop. I think I've fixed that in this version. So when we go back and we look at it, I think when we get into the loggers, we'll see some if conditions that filter out circular dependencies and infinite loops. So I think we're safe here. So we're going to have a lot of the same logger stuff that we were having before. And that should be okay because, like I said, I think we fixed that issue. So here we go. And we'll put this here, same as we did all the other ones. and make sure we grab our wrap-up section of code. Okay, and I got that. Let's go ahead and implement a header. Okay, at function replace double percent with message, and description is parses the input string and replaces any instance of a double percentage sign with the input metadata string. Okay. So this is a string, this is a string, and it's going to return also a string. Okay. The string that might contain the double percentage signs. Metadata is the string that should replace the double percentage signs, and then return the modified string with the message inserted. Author, sign it. Date. All right. Yeah, we should be good here to use these. I think we're going to be okay. And we got that. Set this to equal to an empty message, empty string. And then our return data equals input data dot replace. And actually, I could call replace character with character and pass in the input data and the array b.c percent plus b.c percent and input metadata. Okay, that should actually work exactly the same, and I think we're good. All right, let's move on. A double percent with message. Okay, let's move on. All right, so the next function to implement is called export const remove x number of folders from end of path equals function. All right, so pretty much the same here, except we change this, of course, following our usual pattern. And the wrap up. Okay. And the header at function remove x number of folders from end of path. Description removes x number of folders from the end of a path and returns the newly modified path. Okay, so this will be type string, this will be of type integer, and this is of type string. So the input data is the path that should have the number of folders removed. Input metadata is the number of paths that should be removed from the input path. And the return, the modified string with the folders removed from the input path. Sign it. Date 22. Okay. Now, as for the implementation, Let return data equals an empty string. Let path array, I'm going to declare that, and let path as forward slash. Okay, so if input data dot includes b.c forward slash equals true, path array equals input data dot split b.c back, sorry, this should be forward slash. Okay, path as forward slash equals true. And then we have an else if input data dot includes b.c backslash equals true. Then we basically do the opposite. Path array equals input data dot split b.c backslash. Okay, and path as forward slash equals false. We have an else case. Path as forward slash equals false. And return data equals false. Okay, now down here we have an if return data not equal to false. We're going to have loggers here, so we need to put out a custom message for debugging. All right, that message is path array is plus JSON dot stringify path array. Okay, then we have a loop for let I equals 0, I less than or equal to path array dot length minus input metadata minus 1 I plus plus. Okay, and we have another loggers message. Current path element is path array I. Okay, so if I equals 0, return data equals path array I. Else, if path as forward slash equals true, return data equals return data plus b.c forward slash plus path array I. Okay, else if path as forward slash equals false, return data equals return data plus b.c backslash plus path array I. Okay, else return data equals false and break. All right, so we're going to come down here. I'm going to document this. This should be the end of the else case. This is the end of the for loop, and this hold on, this comes down here. We need to have another if condition here. Hang on a second. Yeah, actually, I'm going to document this. This should be the end. Return data not equal to false. Okay, but I do have another if condition here, if path as / equals true, return data equals return data plus b.c / else if path as / equals false, return data equals return data plus b.c / and another else. It's basically the same as the if condition we had above, return data equals false. Okay, and that's the end of the function. So the next function is export const get first top level folder from path. All right, and much of the same. Make sure that I do that. Yes. Okay. And this one goes here. We really are almost completely done. And let me grab the wrap up. Okay. The header for that is going to look like this. At function get first top level folder from path. Description takes a path and returns the folder at the farthest right of that path. Okay, the input would be a string, and it's going to return a string also. Okay, input data, the path that should be evaluated, not used for this business rule, and the return, the folder at the far right of the input path. Sign it, and date. Okay, all right, implementation time. All right, so we just got a few functions left to implement here. I'll just try and push through to the end. Let path array and if input data, yep, dot includes b.c / equals true. Path array equals input data dot split b.c / okay, else if input data dot includes b.c / equals true. Path array equals input data dot split b.c / and the usual else case, return data equals false. All right, now we have another if, return data not equal to false. We're going to have a loggers message here. Did I do this? Yes, I did. Okay. Loggers. And the message is path array is, oops, I need to put that in a string. Path array is JSON.stringify path array. Okay, and then return data equals path array dot length -2. Okay, and that should do it. All right, next function is export const is odd equals function. And you might be able to put this into a math function. Yeah, but I'm doing this as a string, so I'm operating on strings. Okay, so this is going to be virtually the same as that. Well, not entirely. Hold on. So to finish up the is odd implementation, let's go ahead and do our usual wrap up on the function. Okay, and return data. We're going to start out set it equal to false. And if is integer, input data. Okay, if that is equal to true, then let input value equal parse int input data. Okay, let result equal input value mod 2. Okay, and if result equals 1, then return data equals true. Nice simple way there to determine if something is an odd value or not. And then we're going to have something similar for even. Export const is even equals function input data input metadata. So this is actually virtually identical. Let's just go ahead and paste that right there. And the is even, the only change here is to say if this is 0 instead of 1, then we return true. That all stays the same. We still mod 2, still parse the int, and this is even. We need to implement our our header here. Okay, at function is even, at description determines if the input value is an even number or not an even number. Okay, and then our parameters. This should be a string. Okay. Again, I'm operating on strings. So string and Boolean. Okay, so this one, description of this input should be the value that should be evaluated to determine if it is even or not even. Okay, for the metadata, not used for this business rule. And this one should say true or false to indicate if the value passed in is an even value or not an even value. And we sign it. Date 10/26. Okay, and I do have a note here. Note, this function isn't actually needed, as we can just invert our logic for calling is odd, but I provided it here anyways for completeness. Okay, so that's the end of that one. Okay, we really are getting right down to the very end. And there's two functions left to implement. Export const replace character at index. Function down to return data. Replace character at index. That needs to go right here. And then we have the wrap up. Okay, return data equals false. Let index of replacement and let string to replace with if input metadata. Oh, you know what? I never wrote my header. Let's write that first. That function replace character, character at index description replaces a character at the specified index with another character. Okay, string. This should be an array of integer string. And finally, we're returning a string. So the input data is the string which should have the specified character changed, then returned. Input metadata is an array with an integer of what index the character should be replaced. And a string with the character or characters that should be inserted at the specified index. Okay, and for the return, the modified string. Sign it. Okay, and we have another link here. All right. Yeah. Another Stack Overflow link. And let's get back to the implementation now. Yep. So, dot length equals 2. Index of replacement equals input metadata 0. String to replace with equals input metadata 1. Let string array equal input data dot split. Okay. The string array dot splice input index of replacement 1 and string to replace with. Return data equals string array dot join. Yes, so that's kind of a neat little trick. And the rest of that is perfect. Okay, now comes the very, very last one. We have a note here. So let's bring that down here to the end. This is for, the remainder is for internal functions. Okay. And the last function is export. I'm sorry, actually no, hold on, I don't think we are exporting this one. Yeah, we don't export this function. It's just function does array contain value. Array, value, and my function. Okay, because it doesn't follow the signature, we can't do that. At function does array contain value. And the description is checks if an array contains a value. Checking equality by function val array, the index like that. All right. Now the parameters. Okay, this takes an array of string or object or map. And this takes a string, integer, or an object. And this is a function. And this is a Boolean. Okay, so the array is the input array that should be searched for the given input value. Okay, for the value that should be searched for in the input array. Okay, and the function that should be used to do the search. And the return, a Boolean value to indicate if the value was found in the array or not found. Okay, a note, I'm sorry, assign it, and date. Okay. Now, as for the implementation, it's a little bit different. So let's say let function name equals does array contain value. And then we're going to have these. Although they might change a little bit. Begin function, and then the message here is going to be a little bit different. Input data value is plus JSON dot stringify array. Okay, this one is input meta. Well, it's not input data. This is just array. And this one is just value is value. Okay, and we're actually going to need a third one because we have the function we need to dump data as well. So that one should look like this. My function value is plus, oops, sorry, I need to put that in here. My function value is plus JSON dot stringify my function. Okay, so So we say let return data if low dash dot is array equals false. Then we have a loggers message right here that says array input object is not an array. Okay. Return data equals false. If not array dot find, and we're going to use an arrow function here to call my function I and value. Okay. Loggers function again. Message is the value was found in the array. Oops, I didn't complete my sentence here. Okay. And return data equals true. And we have an else case here. Loggers function again. A custom message that says the value was not found in the array. Return data equals false. And then we have some wrap-up messages and the return the data, which is basically exactly that. So let's just put those right there. Return data as an end function. Yep. So that's the end of this, and I'm going to come back and we're going to have a little bit of refactoring, but we're going to wrap that up, and I'll go ahead and check all this code in. All right, so because all this stuff is done, let me go ahead and set this stuff to persist to the repo. All right, so git status, git add, git status, git commit -m. Let's see here, add all the string parsing business rules. Okay, git status, git push, and there we go. If you find this video helpful, please click the like button below and click the subscribe button and the bell to be notified when new videos are published. This also helps me out and lets YouTube know that you enjoy my videos. Thank you very much.